Paryagi. I request everyone to take the front seat, so it will be good for everyone and for Mr. Paryagi also to address everybody. So request, please come everybody in front, occupy the front seats. And I request Mr. Paryagi to start his session on color management. Yeah, all Mr. Paryagi, stage is all yours now. Before we start, I request Sunil to come on the stage and honor Mr. Paryagi with the bouquet. Mr. Paryagi, please.
Thank you, sir.
Time also we'll revise some of it, but we'll talk more on color management and various aspects related to color management. Why we need color correction, then we talk about how we were doing it conventionally, and the same thing how we are applying it to color management now. Okay, hope it starts soon. In the meantime, any question on what we did last time? If any doubt or any questions? The basic logic remains the same. That's what I wanted to show you. This particular I had done for the company who does the pharmaceutical printing, and this was done by Gravier. Okay, so the basic components remain the same, but you have to take into account the peculiarities of that particular process. So you have to set the machine accordingly. You have to make sure that machine prints as it should with correct setting, and then run the test form on the machine. Okay. This was similarly done for wide web Gravier machine. So we had to go through the standardization of the cylinder making process, printing, and so and so. Okay. And when you do color management, that has to go in stages. So you have to first print a test form like this and make calculations from some special charts, and also incorporate additional information that is peculiar to your company, and then print this stage chart, and you go on. Oh, it started. Okay. Thanks. Okay, I'll show this a little later. Okay. So today we'll talk about the color management. In our business, we get variety of originals coming from all different sources. We get photographic originals. We still get what are the conventional photographs, analog photographs. We get digital photographs. We get black and white photographs, color photographs, prints, transparencies, negatives. Okay, and these are made on different types of films. A film coming from Kodak or Agfa or Fuji, which again has different characteristics. We get artist originals. Artist uses variety of colors, and we have to print it in CMYK, and occasionally with special colors. We get graphic originals, or we create bars, charts, and so on. Then we have typefaces. We have in some certain printing, like say for example pharmaceutical, we get very fine text like the batch number or the fine instructions, and so there are types which also should be reproduced legibly. People should be able to read the type. We get digital originals coming from variety of different file formats. Some are compatible, some are not compatible. So in printing there are two things which are important. If you are involved in producing the pictures of personalities like film stars or sports star or politicians and so on, what is important is the skin tone. The skin tone, the person has to look like a person, okay? Even if the dress is slightly different, it doesn't matter. And in case of packaging, the color of the package should be produced nicely, okay? Doesn't matter what color it is. People expect that to increase their sale, they want the original company who puts the product on the market, they want to see that their product color is reproduced as it's in the real life. So if we don't do this, then we get dejected customer because he doesn't like the job, and then everybody is in problem. So we have variety of printing processes. Basic color management logic is the same, but for each process, we need to set the machine, we need to take care of machine components, we need to take care of consumable that we use in a particular process. We must standardize them scientifically. If the pressman is setting the press differently every time, the color management is not going to work. Actual color comes out of printing machine. Unfortunately, many times color management is taken as only something for the pre-press. It's not so. Color management is for the whole company. Only pre-press man, he doesn't control the machine. The machine man has to control the machine. He has to set it right. Actual color comes out from there. So we have variety of printing process: litho, offset, letterpress, flexography, gravure, screen process, digital printing. Okay. And each process has variety of variables. So I just listed only the basic variables. In litho offset, you have used fondant solution, you use offset blanket, rollers, different types of plates, and you have different types of machine. So each component must be set, must be taken care in preventive maintenance, and must be set as it should be. Letterpress, again we have, don't think letterpress is obsolete process. Letterpress exists in its modern form today very widely. SL Propack, they print most of their tubes by letterpress printing. It's a photopolymer letterpress plates, okay? So most of the people, when they talk about letterpress, they think it's obsolete, it's old type and so on. You have to look at the modern letterpress process. So there are different types of plates, different types of machines, roller setting. Flexography, you have analog rollers, doctor blade setting, different types of plates, different types of machines. Each one needs to be set the way it should be, okay? In gravure, you have image cell structure of the on the gravure cylinder, the cylinder making process, whether it's conventional, electronic or laser, the type of gravure machine. In screen printing, you have type of screen, what is the screen mesh, what kind of stencil has been used to produce the screens, and the type of machine where we are going to print. In digital printing, you have half-tone methods, you have continuous tone methods, FM, inkjet, thermal, dye sublimation, electrostatic, magnetographic, what is the end-use application, and the type of digital machine. Then we have other variations. What is the screen ruling we are using? What is the cell shapes in gravure? What is the screen angles? What is the color sequence? I want to show you one example of screen ruling. When you run the test chart, you must run the test chart, the screen ruling that we are going to use in practice, okay, and the dot shape that we are going to use in practice. If you change that after test form, your color management will not work correctly, because the dot shape, when it goes over 30%, 25-30%, it starts slightly overlap two different dots, two different color. And the shape will decide how much overlap will be there. In some shapes the overlap is more, in some shapes the overlap is less. So that is also going to change the color. So you must run the test form with all these things in mind. So here is one example. This I had done a long time back. These are the different screen rulings, cyan, magenta, yellow. And here, when you run this, if you run a test form, for example, I have say 150 line screen, and in production, if your screen ruling comes down drastically, if say 65 or 85, then your gray starts looking slightly pinkish. If it goes too fine, maybe 250, 300, then color gray will start looking slightly greenish. So it's important that you run the test form with the screen ruling that you are going to use in production. Yeah, you can make some average over a short range, but it should not be extreme. So that's very important, the screen ruling and the dot shapes. Then screen angles, color sequence, cell shapes are very important in gravure. You get variety of shapes. It indirectly changes the volume of ink that is deposited onto the substrate, and that makes a big change to the density and ultimately to the color. In first talking about CMYK, now inks have certain deficiencies. That is what we need color correction. If the inks were perfect, we don't need color correction. But the inks, all the dyes and pigments available in the world, they have some deficiency. The pure dyes and pigments are not available. Whether it's in paints, it's in artist color, whether it's in ink, whether it's in television phosphors, okay? Everything has slight deficiency. For example, here I am showing the example of cyan, magenta, yellow ink. The cyan ink can be it will become clear after 2 slides. Each ink occupies certain part of the visible light. Ultimately, the color comes from the visible light and the spectrum. So that spectrum decides which portion of the spectrum is entering your eye, and it gives you the impression whether it's a cyan color, magenta color, or yellow color. Okay? And that color, whether it has slightly tinge of the other color or not. Okay? So if you see cyan here, now one side, sorry, this is a gray error. So the ink becomes more dirty, ink starts looking dirty. Ink does not reflect the full light that is coming from the ink. And this deficiency of light reflection, we call it a gray error. Absence of light is black. Okay? So when the light reflection goes down, ink starts looking gray and gray. Okay? It's like you walk in the evening, late evening, you know, all the colors will start looking grayish and grayish. You don't see pure color when light is not enough. Okay? So each of the color can become dirty if its gray error goes high. And this is U error, sorry. So here, for example, if you take the magenta, it can be reddish magenta or bluish magenta. So that's we call the U error. Okay? So all these inks, they suffer from that kind of deficiency, and these inks coming from different ink companies or different series from the same company will be different in its U error and gray error. Okay? So the correction required for each set will be slightly different. It cannot be same. Now these inks, I will go to the next slide first, I think. This is what I mean. If you take the whole spectrum, and the spectrum is divided into 3 major parts, 1/3, 1/3, 1/3. There is a pointer here. No? I think battery is probably out. So if you see, this whole thing is a spectrum like rainbow color, and the spectrum is divided into three parts. So when you divide the spectrum into three parts, the first collection of first 1/3 wavelengths, it appears as a blue light. The center portion appears as green, and the third one appears as a red. Okay. So there are three distinct parts of the visible spectrum: blue, green, red, which are basic color like we talked last time. So here, when that also we talked last time, when two colors are reflected, it gives us a secondary color. Okay. When 2/3 is reflected, it gives a secondary color, and 1/3 is light is suppressed. When all are reflected, we see white light. When nothing is reflected, it's a black. So here, in the first diagram on the top left, the blue and green is reflected, red is not reflected, and the combination of blue and green gives us the effect of cyan. What is it? So whenever we see our cyan ink, it's reflecting blue and green light. That combination gives us the impression of cyan visually. Okay. When blue and red is reflected, it gives us the perception of magenta color. There is no green. Green is completely absorbed. And when green and red is reflected, it gives us a perception of yellow. Okay. So that's how the inks work, or yellow, magenta, cyan, color, and they work. So here, when we see this color, for example, now again look at the top left. The blue and green is reflected, but neither blue nor green is going to 100%. Okay. So there is no light which is reflecting 100%. Okay. So that is less than 100%. So in that gray area, there is no light exist. So it gives the impression of dirtiness or black. Okay. That we call gray error of the ink. So this gray error can change with different sets of ink from the ink manufacturer. Okay. Some inks will look more dirty than the others. And if you see this between blue and green which is reflected, this blue and green is not equal. Blue is more and the green is less. So therefore the cyaning gives the appearance of a bluish cyan. Okay. So that we call hue error. So this is what decides our color correction in our printing process, or in the photography also it decides the same. In television, everywhere it's the same. Okay. So these deficiencies decide how much correction is required, and this data can also be measured. Nowadays we don't need to measure, but these fundamentals are important to understand why we need color correction. This can be measured with the simple densitometer. So you can measure with the densitometer. Say there is cyan, magenta, yellow. You can also measure red, green, blue, 2 color patches and 3 color combination. When you measure through a densitometer, again densitometer will measure through red, green and blue filter, because back to basics. Yeah. So if you want to measure cyan ink, whatever you want to measure, it should appear black to the instrument. Like when we read the book, we have black text on the white paper. Good contrast, that is why we are able to read it. If it's light yellow color, there is no contrast, so you cannot read the text properly. Okay. So the same thing here, when you measure the ink, that ink should look black to the densitometer, then only it can measure it properly. So since cyan color does not reflect any red light, we measure cyaning through a red filter in the densitometer. So the modern densitometer will automatically bring red filter in the light path. Earlier we had to rotate the filter wheel manually. So you measure cyaning through the red filter, you measure magentaing through the green filter, and the yellowing through the blue filter. Okay, so when you measure the densities, this is how you will get. So you will get, see, the cyan through a red filter is measuring highest density because no light is reflected. Green and blue. So from this you can calculate also what is the gray error and hue error. On some instruments you will get direct value, what is the gray error, and so you don't have to calculate. But this is the way it is calculated in the densitometer. Okay. So these can change with different sets of inks. Now, when we do the color separation, old days we used to do it manual color separation on the camera. Still the same principle exists. There is no change, because ultimate object is to put the right dot size on the paper, on or whatever substrate you want to print, or aluminum foil or other foil, anything. Okay. So that principle has not changed. It cannot change. You have to put the right dot size. So to achieve that, what process you use, from old time to the modern time, that technique will change, but the basics will not change, because you have to put the right dot size on the substrate. So here, because of this deficiency, we see, when we do color separation, we separate color original into red, green and blue component. Back to basic colors, red, green, blue. Okay. This is what we used to do long time back. Actually insert the filter, make the separation. Today's scanner is doing the same thing. That's why they are called RGB scanner. Okay. It performs the same thing, but it performs it electronically. There are circuits, and one will have red signal, one will green signal and a blue signal. So when you do it, you make the separation. And because of the deficiency, now when you make the separation, what you want? You want the final separations or the printing plates. When you put on the machine, the cyan ink should be deposited only here. Okay. And if you are making 3-color black, then cyan here and here. Okay. You don't want cyan here, here and here. When you want magenta, here and here, yellow here and here. Okay. So when you make the plates or you make the separations, your separations should become like this. Okay. But because of the ink deficiency, we get unwanted dot in unwanted area. So when you combine these faulty separations you print, then what is going to happen? In some areas you are going to deposit other colorings, and which will give you muddy picture, dirty picture. Okay. So our job, so old days, the people, skilled people, retoucher, they used to work on the separations, and manually they used to remove these dots which are not supposed to be printed. So that we call manual color correction. Okay. That is manual color correction, and they have to remove the dots from this unwanted area and make it clean. Okay. So then as the technology developed further, then we came with we started using photographic color separation, in which we used to combine 2 photographic films to make the final correction. We started achieving the same thing by using this photographic masking. So there was a scientific method, there was a scientific calculation based on mathematics, log tables and all that. We used to do this, okay, and to get this final result, what people used to do manually. Okay, so this was photographic color correction. Then the scanners came, which started working on the same principle. Oh, what happened now? Scanners came, started working on the same principle. There were electronic signals joining different, images which are coming, and then signal generated combining with another signal and give the final correction. Okay, that was the same thing. But object was the same, to achieve correct color separations. Then the same time there was some mathematics involved, because basically when you print, there are only these areas you get if you print in CMYK. There is area where no ink is deposited. You print cyan, magenta, yellow. Where two color combines, we get red, green, blue. Okay? And where three color combines, we get brown, and then we also add black. So we add black. So these are all the colors that we get in any color reproduction. So if you look at the minute dots, you get those basic dots, and also combined with the black. Okay, so those are the colors you get. So therefore there was mathematics which is based on that. So there are some scanners which work on this method. So there were scanners which worked on photographic masking mathematics. Scanners came which work on this mathematics. The ultimate object was the same, that you put the right dot size on the substrate of each color. Okay, so I showed you those ink deficiency, U error, gray error. Because of that, if you try to print dot area of cyan, magenta, yellow of the same size together, it looks brown. It doesn't look gray. Now let me explain you once again. This is very important whether you use the new color management or the old system. So here cyan ink reflects blue, green, somewhere around this. Magenta, so much blue, so much red. And the yellow, so much green, so much red. When you combine the three inks, what you find, there is, because of these two, there is more reflection of red light than green and blue. So you can see the red light reflection is highest. The blue is only up to here. Okay? The green is only up to here. But the red is the highest. So therefore when you combine three ink, it looks reddish brown. It doesn't look gray. Okay? So this gray balance is the most important things we have to achieve in any color reproduction. Whether you use ICC profile color management, whether you use the old system or whatever. Okay? Because when you print these three together, you don't get black, you get reddish brown color. So we have to convert that reddish color into gray or black. So how do we do that? Red is suppressed by the cyan. Cyan ink will not give red reflection. Okay? Yellow and magenta is giving red reflection. So to suppress that brownish effect, reddish brownish effect, we have to deposit more amount of cyan than magenta and yellow. So more amount of magenta will suppress that extra reddish tinge that you get from three color. Okay? When you print in equal quantity, cyan, magenta, yellow is give you brown. So we need to print higher quantity of cyan, then magenta, then yellow, okay, to make it gray. Because in any reproduction, the gray has to look gray. Even on television, when you set your brightness and contrast, you turn the colors off and you set your contrast and bright, okay, looking at the gray. In reproduction, the gray scale is very important. If the gray is gray, most of the colors will automatically look all right, okay. So this is the first and most important requirement of the color reproduction, that you, with colored inks, you produce gray. With 3 color inks, you produce gray. So this is what I was showing you. This is only 3 color, there is no black. Okay, so 3 color has to produce gray. That's the first important. Then your inks are printed in balance, you can say. So you need more amount of cyan than magenta and yellow to make it gray. Okay, so you print higher amount of cyan, then magenta, yellow. So 3 color makes it brown. So after making gray, you still get problem from mid-tone to shadow. It's still not completely gray. So therefore we need to add black, okay, to get depth, better grays in the shadow area, mid-tone to shadow, okay, and the details. So anybody has attended this G7 course? I mean, they talk about the gray. It's the same thing, nothing new about it. It has been there for a long time. For the last 50 years, people are talking about gray. So when you make your ICC profile, the first you must find out what is a gray, and then put that gray balance before you make ICC profile. So it has to be part of the profile. Your gray balance has to be part of the profile. Otherwise the profile is not going to work. Colors will not look right. So when you produce this gray, you have to also set standard, what ink sequence you are going to print, what screen ruling, what dot shape, okay, and so on, and all your printing conditions. Printing conditions should stay consistent as possible. So certain things you must always, strength of the ink. If you, once you select the ink, and if the strength of the ink changes with a new lot of ink, to get the same density you will have to deposit more amount of ink. Then your dot gain will go high. So all the problems start, okay. So you must regularly check what is the strength of the ink that you are getting, each lot. Sometimes it's easier to make ink cheaper by reducing the pigment content in the ink, because pigment is the most expensive. Okay, but then your ink consumption can go up. The dot gain will go up. Your details will start filling in. Then substrates. You print on different types of papers. Yeah, map litho, art paper, board, okay, synthetic papers like Tyvek, or substrates like this, aluminum foil or whatever, and ink. So when you print, you cannot print lighter tone than your paper. The paper is the lightest color that your picture will have, okay, and the darkest tone in the picture will be the solid patch of that ink on that paper. So you have to play within these two extremes. You cannot print darker than your solid patch of ink. You cannot print lighter than your substrate. Okay. So that is the limit of, we say, of your reproduction. So your print density and what originally you are getting, if everything is perfect, you will get diagonal like this. That is, every tone in the print will match the every tone in the original. Okay? But that's a wishful thinking. That doesn't happen. So when you get art paper glossy ink, you are still not with the ideal. Your density is lower. Okay? If you print on, say, dirty paper, newsprint for example, the base is dirty and the top density is very low. So that is the limit of our reproduction. So any original, what is happening? Any original you have to fit within the limit of your ink and paper. You cannot expect the same result that you get on the art paper to get the same result on map litho. It's not possible. To show you some. This I had done long time back, so it's not in a very good shape, but still. This I had done in Shivakasi long time back. This is the art paper and this is the map litho. Yeah. Yeah, because of the ink and paper. But within the limits of ink and paper, this is also good. That is because of this limit like this. So you cannot get this result on this paper, but you have to work what is best on this paper. Okay. So that's where you have to get your tone reproduction right. All your tones must give you nice details. Doesn't matter what paper and ink you are using. Okay. So this is when you also do the ICC profiling in color management, you get what you call gamut mapping. So this is gamut mapping, that you are compressing your tone according to your ink and paper. So first is gray balance. Second most important thing is tone reproduction. So the tone reproduction depends on the dot gain. The dot gain on the monitor display and what you print, there is always a difference. Okay, your dot spreads in the printing process. So that difference we call dot gain. So this is what decide how your tone reproduction is going to be. So your tone reproduction depends on dot gain, cyan, magenta, yellow, black. And again, it's not the same for all the colors. Some inks will spread more than the other. Okay. So this dot gain, when you look at the gray balance, that has to be looked at after dot gain. After dot gain, what is the gray balance you are getting? Tone reproduction you are getting. So this is what it is. Oops. Why is it making noise? One minute. Let me keep this quiet.
It's okay.
Oh. So this is white surface glossy ink, other substrates matte inks. So this is what you get, but that's the limit of that ink and paper. So you have to get the best within that. Okay. So this is the best reproduction with that ink and paper. Paper may be inferior, but that's a limit. Then we add black to cyan, magenta, yellow. So one on the left is called skeleton black, one on the right is called full scale black. When you get your grays right, you find from highlight to mid-tone, your grays are looking nice. But once you cross the mid-tone and go over, it's difficult to get good gray. It starts looking a little bit brownish. Okay. So therefore, in one case, you can start adding black where it starts becoming brownish to turn that brownish into gray. So that skeleton black will do that. So there is no need to add black below the mid-tone because it will make only picture dirty. If you can make gray with 3 color, many times there is no need to add black below that. Okay, in the lighter areas to keep it clean. But we start adding black where the grays are becoming brownish to make it into gray. So that's a skeleton black. The one on the right is called full scale black. It starts right in the highlight. And that kind of black you need if you are applying what we call undercolor removal, gray component replacement, that is UCR, GCR, or nowadays some supplier came out with a new term they call it ink optimization. It's nothing but the UCR, GCR. It's old technique, yeah. But people need something new to talk about. Okay, so then you need full scale black. Okay. So in picture we have colors and grades. If you do only UCR, that is undercolor removal, you are reducing cyan, magenta, yellow only from the gray area and not from the color area. So the grays, what you see below there, that instead of printing with 3 color, we print with only black ink. Okay, that is UCR, undercolor removal. It affects only grays, it doesn't affect color. There is another so this is UCR. 3 colors replaced with, wherever the gray color is there, it's replaced with black. Affects grays only. There is second technique called GCR, gray component replacement. Affects all colors including grays. So it will affect color as well as grays. So it's like this. You have particular area where there is 90% cyan, 50%. It happens in all. I'm just giving one example. 90% cyan, 50% magenta, and 70% yellow. So if you see this here, the actual color you are getting only from excess color, that is 90%, where 90% cyan is and 70% yellow is, 50%. So above 50, cyan and yellow, we know from our basic theories, cyan and yellow makes it green. So this will give you greenish color. But because also there is a lot of magenta, it gives us dirty green, yeah, like olive green and so on. So this is greenish tinge, dirty green, which you are getting because of cyan and yellow higher than magenta. So when we do GCR, what we do is, because below 50%, these 3 color are only making it dirty. So the principle is, instead of making it dirty with adding 3 colors, let us make it dirty by only with black. So you only print extra portion of cyan and yellow, add black and make it dirty. Okay, that is the principle behind GCR or ink optimization, what you may call. So we cut this out and we print black. Okay, so the dirtiness we bring with the black ink. So we reduce the coloring consumption and make it dirty green this way. But this cannot work well on all the pictures. On some pictures it is alright. If you say lady's face, And if you try to apply this, the face will look like, as a lady has shaved her face. So some mid-tones will not look right. You will get harsh colors. So this is all right for some subjects, not for all. So when you make the color profile with the ICC color management, all this can be incorporated before you make the profile, and then with all this information you make the profile. You make profile with gray balance, correct tone reproduction, whether you want UCR, GCR, all that can be part of the profile, dot gain. Okay, so when you apply the profile, everything is taken into account. Old days we used to apply everything separately in stages. Okay. It affects all colors including grays. Then when we print, and especially in the shadow, if you have good depth in the shadow, and if you print all the colors, 100% cyan, 100% magenta, 100% yellow, 100% black, the area becomes very heavy, and because of the ink trapping problem on the machine, the second, third, fourth color may not sit properly in that combination. So you get what we call trapping problem. Trap is how second color is sitting on the top of the first color. So it's never 100%, it is always less than 100. So when you deposit this heavy ink one over the other, your shadow area will not get good deposit of the second, third, fourth color, and then we have a trapping problem. Okay, and therefore it is not necessary to print this 100% because it's going to cause trapping problem. Besides, when you print say 80% in all the colors, that becomes 320%. If you print 90% in all the colors in shadow, it becomes 360%. So when you have that kind of deposit in the shadow area, you may not get the details when you go above certain limit. So this area will get filled up. So the density at 80% and 100% may be same. 100% may be a little bit less because of trapping problem. Okay. So we have to decide what is the total ink weight that we can print. Because if you are getting good density, then you may print say for example at 80 all the colors. So that is 320. We call that total ink weight. If you go over that, it's not going to give you any increasing density. There is no difference in tone. Okay. So this kind of chart helps us to find out what is the total ink weight we can print. If you take ready-made profile, ISO 39 or some others, it has built-in total ink weight, but that may not suit your printing condition. Okay. So therefore, I always prefer when I do my work to find out what is the ink weight that I can print for a customer. Okay. I'll show you again. So there is so this I decide what is the for that particular customer what is the total ink weight print, and that value becomes part of the profile. So when you apply profile, all these things are applied automatically. So this kind of chart is useful for that. So therefore I include all these charts when I make my test form. Okay. I don't use ready-made just single test form because it doesn't work. So this is UCR, GCR. On the left is the UCR example, on the right is the GCR example. So you can see this area especially. Yeah. Here the colors are reduced only from the gray areas. Here they are also reduced from the color areas. So that's the difference between UCR, GCR. So this is, I designed my own test forms, something like this. So I assemble individual components. I have some standard pictures which I put in. I also tell the customer what they want their representative pictures. Along with this, I also put that if they want. And I designed this test form to the size of the machine. If it's 2840, 2029, or big one like this gravure machine. So I cover the full size of the machine, so that then we also can find out if there is any problem in the machine. So this is the color management test chart. This for total ink weight, that's for the gray balance. These are the scanning targets. This for the trapping. There are fine, type, reverse, normal. Okay, 4 color, single color, fine lines. Other control elements, density bars, top and bottom. These are slur bars, and these are plate making targets. Yellows, cyan, black, magenta, and so on. Okay. So, and then we record the information, what condition we have used, what paper we have used, what inks we have used, and so on, what fountain solution, or depend on the process. For gravure, what cylinders we have used, or flexo, so on.
This is also fingerprinting, what is
This is called fingerprinting. Any process you carry on to find out or to check the printability of your machine is fingerprinting. Whether it's a digital machine, offset machine, letterpress, gravure, flexography, anything. Okay. So when we do this, we also make sure that machine is set properly. Then we get what is ink trap, we get what is dot gain, 3 color gray balance, tone curve, scanning curve, slur, control strip, text elements, fine lines, how the color scales are coming, color management chart, scanning chart, 4 color tone curve plus total ink weight, and some test pictures. Okay. Then we work out what is the gamut. So once we get all this information, gray balance, tone, dot gain, everything, then we make the profile. Then we know what is the gamut that we are covering. Then we can compare on the same machine with different papers, how the gamut is changing, how the tones are compressed. Okay. So this is just a comparison. The human eye can see maximum number of colors. What we see on the monitor is like this, or photographic film. This is Pantone special colors, and this is CMYK. Okay, so it will be different depending on your printing conditions, inks, paper you are using, because it depends on the tone reproduction limit. I showed you a slide earlier that decides this gamut. Okay, so old days we used to use color charts like this. I mean, you may still have, because some designers still work with this, but it's not a good indication actually, because color charts, okay, they may be printed on different paper using different ink. Your ink and paper may be different. Okay, your dot gain may be different, and so on. But this gives you combination of all the colors just as an indication, not the. Then there are reference catalogs like Pantone, which are used in packaging. Pantone, Focal Tone, NIK, and so many catalogs are there. Now Uber Ink has come out with that is micro. They have come out with the special chart called CRS chart, which they claim is better than Pantone. Okay, so here there is indication of color and how the same color can be reproduced in CMYK or so on. So in color chart we look at the color reference, customer sample, we look at the matching color in color chart and we say, okay, this color can be reproduced with so much of cyan, magenta, yellow and black dot. Okay. But it is very important that substrate endings should match production if you want to use color chart. The dot gain in color chart may be different than your machine. Okay. Very important, dot gain allowance is taken care. Color sequence. You must, maybe color chart and your printing may be having different sequence. We don't know. It all depends. Yeah. So that is important. Very important. Ink sequence is the same. Viewing light. It's a very, very important thing. The light under which view we see should be controlled light. Otherwise the light which gives different types of colors. See on the left, this highly bluish light, this is yellowish light. So the colors are going to look different. Okay. So there has to be some control lighting to judge colors. You can see there is a wide variety of lighting. Computer monitor not calibrated, it will be at 9300 degree Kelvin. That is very highly bluish light. Okay, as the color temperature goes up, we discussed this last time, color temperature. When the temperature is high, the light looks bluish. When the temperature is low, the light looks yellowish. So computer monitor, average daylight, fluorescent lamp, xenon, sunlight, balanced light is here. Then other lights, fluorescent, okay, right up to the candle, down to candle flame, you can see 1900 degree Kelvin. So there are a wide variety of lighting. So for color reproduction, we must have control lighting. You are in your place, at your customer place. You have to agree on the, since you have to agree on the color, it's very important. Then what is the intensity of light? You may have the right color, but if the lighting level is very low, then you cannot see the colors properly. Like in the evening or early morning, the lighting level is low, so you don't see colors properly. During the day, when the lighting level is up, you can see colors better. So there are a variety of conditions. Then there are densitometers, we talked last time, which can measure only cyan, magenta, yellow, black inks, because it works on that 1/3 of the spectrum principle. It cannot take variation within the 1/3. It can measure only 1/3 of the light. But there are instruments which we need to use, because especially in packaging and many times in other printing we also use special colors. To measure special color, we need instrument called colorimeter, which can measure variation within the 1/3 of the spectrum. Okay? Any question or okay? Then the next thing coming up is a spectrophotometry. Colorimeter measures at 3 points which coincide with the human eye sensitivity. But if you have two colors where the spectrum is like this, one is this, one is this. So at these points they are very close, almost identical. But in this area, this color is reflecting more red, this color is not reflecting so much red. So this is where the colorimeter is less useful, where you need instrument called spectrophotometer, which measures the entire spectrum, all the wavelengths of the spectrum, and gives you better indication of color. If you measure only with colorimeter, some colors will match under some light, but it will not match under other light. This we call metameric match. But if you measure the color with spectrophotometer, and if spectrum is the same for both the colors, then under any light it will match. Okay? So you need the spectrophotometer which will measure throughout the spectrum. So now we come to digital color management. We talked about the conventional gray balance, tone reproduction, dot gain, trapping, everything. All those things are applicable here. Okay? So in digital color management, can we go ahead or you want 5 minutes break? Huh? What about you? Huh? Continue. For students probably it's very high level, is it? But this is very important, since as a packaging student the special colors are very, very important. Can we go ahead? Sure? Okay. So in color management there are a few things we must understand. We talked about the basics, so same thing applies in color management. So there are a few things we must understand. What is device independent color? What is CIE system? Measurement instruments, Apple Color Sync, creation of profiles, calibration routine, and what are the prerequisites for color management. Some of these things we had talked last time, but there are some misconception. Notion that software alone will do the trick. You must have your machine right if you want to do color management. Software will not work on its own. Casual approach to process beyond the pre-press activity. We think color management is only for the pre-press, it's for the entire press. Machines have to be set right, inks must be checked. Lack of continuous and persistent efforts to improve production methods. Inappropriate environment and viewing conditions. Uncalibrated equipment and materials. Lack of proper instrumentation. Improper knowledge, wrong procedures. Lack of appreciation by the designer that we have limitations in the printing process. Okay? And progress and limits of current technologies. There are some limitations of technologies. So device dependent color is a color that you get which depends on a particular device. Okay? So if you are using digital camera, the sensors, how it generates the color, your color what you get depends on the equipment that you use. If you take expensive digital camera and a mobile camera, there has to be difference, because expensive digital camera will have good components, good quality. Okay? Cheap cameras will have cheaper components, so the color you get will not be the same. So that is device dependent color. So digital cameras are, they work on red, green, blue principle, basic color. Color scanners, again RGB scanners, separating colors into basic components, red, green, blue. So the color that it generates depends on the components which are used. Okay? Cheap scanner, not so good color. Expensive scanners, better color. Monitors, you get cheap monitors, you get expensive monitors. So how they display the color, it depends on the type of monitor you are using. Expensive monitor will have better components to generate good color. Okay? So monitor is also RGB. In printing, we print CMYK. In photography, it can be only CMY. So the color that we get, it depends on the printing system that we use. Ink, substrates, printing machine, okay, whether it's digital machine, flexo, gravure, offset. So the CMYK, the colors will vary depending on the printing system. Okay. So in photography only CMY, or sometimes in gravure only CMY. Then we add black. So CMYK. Okay. When we make or create, or in the prepress, when we adapt the design, we send it from computer to print. Okay. So there are good computers and bad computers. I mean, bad means not so good for color management. So between the PC and the Macintosh is much better equipment for color management. It has a built-in color management system called Apple Color Sync, which is a part of the operating system. So it's available to any program that you use. There is a Apple Color Sync, it's part of operating system. Then there is a interface. Color Sync has an interface to the, it interfaces with the application software like Adobe Photoshop, Illustrator, so on. Corel Draw to some extent, but not very good. But Adobe Suite, it works very well. And then some suppliers give the ready-made profile, but their ready-made profile may or may not suit your condition. Its gray balance may be different, tone may be different, okay? Total ink weight could be different. So user custom profile, that is most appropriate for high quality. Okay? So these profiles work on Apple Color Sync, which is part of the operating system, and it works much better way than color management in the PC. PC doesn't have good color management. So you have scanning or digital camera. It scans in RGB, or digital camera gives you RGB images. So RGB images, it gives its color in terms of what is the red value, green value and blue value. Okay, that's why we call it RGB. Colors are reproduced using three basic lights: red, green and blue. So this is a particular value of, say, X color. That color is displayed on the monitor. So what it does is, this particular color, what the scanner has scanned, it looks for the nearest match what is on the monitor. So monitor nearest match probably could be something like this. Okay, and then we send this color to the printer for print. So we print in dot percentage. Some printers can also, in photography, can give you density values. So you get CMYK. So converting from here to here, here to here is done through what we call the interpreter. If there are different people, say if you get South Indian fellow, North Indian, somebody from East India, if they speak their own language, they will not understand each other. So they need the interpreter. So this needs some kind of an interpreter to convert this color into this color into this. Okay. So this interpreter is in the form of CIE LAB, what we discussed last time, or LCH. So any color coming from anywhere, it goes through this box, it goes through this interpreter, because any color can be expressed in terms of LAB. Okay, like RGB cannot be converted into CMYK directly. It has to be converted to LAB, and LAB will then convert into CMYK. So each device will convert its RGB values or CMYK values into LAB. Okay, and then LAB will convert it into the appropriate device language, whether it's RGB or CMYK, okay, and get to the nearest match. So this is CIE LAB is an interpreter which can make any device talk to any device. So this CIE LAB we call device independent color. So earlier RGB, CMYK, those systems are device dependent color. CIE LAB is a device independent color. Okay, it's not related to any device, it's related to the how we see color. So we use some chart like this. This chart we print on our printing machine, whatever printing machine you have, your conditions. So you have to print this under your own condition, which will give you how your machine is printing, printability of your machine. And along with this you must print the other information which I showed you earlier, for gray balance, for total ink weight, for dot gain, and so on. So once you print this in CMYK on your machine, this CMYK is in dot percentage. So if you see 50% of magenta on the art paper and the same dot on the map litho, though the dot area is same, the color doesn't look same. Okay, color looks different. So CMYK is a device dependent color. It depends on where you print, what you print, which machine. But any color from that CMYK can be measured in terms of LAB. Okay, so LAB, CMYK can be converted to LAB direct. So we print on the printing machine, whatever printing machine you have. This I'll just come back little later. Then when we scan in RGB. So this target scan or taken on digital camera, it has various colors. So that RGB can also be measured in terms of LAB. So LAB becomes a common language, whether for RGB or CMYK. Okay. So after printing, we have to measure the color, and you have to, in printing normally we take 2 degree. So in your instrument you will have setting for 2 degree. So you must set your instrument for 2 degree and measure all the patches or measure the color. Okay. This is used in paint, textile and other industries. When you are measuring LAB, normally we measure LAB without filter. Okay. But some people also measure, they cut down the UV light. So there are different filtration in the system. So you must set your filter and must be consistent with that. So from what we measure from scanning or digital camera, what we measure from the monitor chart, what we measure from the printed chart, we create what is called ICC profile. Okay, the software will produce ICC profile, and the scanner profile can be loaded onto the computer as a RGB profile, scanner or digital camera. Your monitor profile can also be loaded as a RGB profile, which you measure, and the CMYK profile can also be loaded on the computer. So we'll come to that, so don't get confused. So when we measure monitor, when you calibrate your monitor, you get various patches like this. So you have patches to measure your printing, you have patches to measure your scanner or digital camera, and there are patches also to measure for the monitor. So the monitor profile will be created measuring these patches. And this is how the workflow goes. RGB is converted to LAB, and this LAB, when you want this image, when you want to view on the monitor, from LAB it is converted to RGB to see on the monitor, because monitor is RGB. If you want to print, is converted to CMYK, so we print in CMYK. Okay, in photography it will be only CMY, but in printing it will be CMYK. So this information going through LAB can be converted into RGB or CMYK like this. This is like a color workflow. Now we also get, sometimes customers send the picture which are in CMYK. So the CMYK customer picture can be converted to LAB, and then you can convert it to your own CMYK profile for printing. Okay, or to display on the monitor like this. It's slightly confusing here, but you have to just it's a, where the color course can be much longer, much for a longer duration. So we are only talking about how it works. The color management system, then it can work like this. RGB file is input, converted to LAB, and then for display converted to RGB again, or for photographic output. CMYK input, CMYK converted to LAB, then for printing you may convert it to CMYK, or for display it can be RGB. Okay, this is how the operating system works on your Macintosh. Okay, so there are a lot of interconnections within the computer, application software and Apple Sync and so on, display. So you need to, when you calibrate your monitor, and if you want to see your image as you will see in the final print, you need two profiles, one over the other. One is a basic monitor profile. You calibrate this monitor to your lighting conditions, flare that is coming and so on. Like you adjust your TV, brightness, contrast, colors you adjust on TV, you need to adjust this. So those settings will stay in the graphic board of the computer. And after that, you load your printing profile. If you are going to print on map litho, on this basic calibration there should be your map litho profile. If you are going to print on your art paper, on the basic calibration will remain the same. You load your art paper profile. If you are working something like this other substrate, you load that profile. Then your image will look as you are going to see it after printing. Okay, then correction with that visual is much better, because then you can visualize how your image is going to look like after printing. So calibrate the monitor. Okay. Then this called color gamut mapping. You are adjusting your monitor to your printing condition. Okay. This is little bit complicated. Just forget about it. But when you make ICC profile, this is what happens. Internal structure of the profile. You don't have to worry about it. When you do it, it happens automatically. Okay. So that is device color, RGB coming. Like I showed you, tone reproduction, limit of tone reproduction. So each color will have its own tonal curve, red curve, green curve, blue curve, like you see in the Photoshop. Yeah? Some of you have worked in the prepress, or maybe if there is time I will show you afterwards in Photoshop. So there is, image is basically made of 3 color. So there is a red curve, green curve, blue curve. Okay, so that is called 3 by 3 matrix. Okay, this I am just showing you for your background now. You don't have to worry about this. And here, this is 4 color now for printing. Okay, so it goes through matrix like this, through the computer signals and so and so. If customer is sending CMYK file, that can be converted into LAB, and then you convert to your CMYK. So when you compress the color to suit your printing conditions, how you compress, that is important. One is called perceptual compression. In this, all the colors are compressed to fit within your ink and paper. Paper is the lightest color, solid ink is the darkest color. So tones are compressed within that limit. Okay. So this is what happens. This is your tones in the original. In printing, this is your limit. You cannot print beyond this. This is your limit of printing. Okay. So, but you still want to get these colors. You want to keep these details in the picture. So in perceptual, these colors, this is your limit, so you cannot go beyond that. So the colors which are outside, they get compressed from the boundary to like this. So you still keep the details, but the details are compressed. So this we call gamut mapping, to fit within your ink and paper limit. So this gamut mapping will still keep the details like the original, but it's like fooling the eye. You are reducing the details, but you are maintaining the detail. Okay. So when you apply perceptual compression, it becomes like this. It is good for pictures, photographs, and so on. There is second one, which is absolute colorimetric. In this one, this is limit, but these are the colors outside. In this, the outside colors whatever the colors are outside, they just come and sit on the border. So you lose the details. But this is good if you are printing, say, logo color, logo of a company or some brand color. Then this kind of comparison gives you good result. And when you do absolute colorimetric, and if you have also digital proofing along with your printing, if you proof that picture or that job on the digital with absolute colorimetry, it also stimulates the paper color. So your digital proof doesn't look very white. It will take the color of the paper that you are printing on the machine. If it's mapped like on newsprint, then it will show you that color. So you get better representation in digital printing with this. There is another one is relative colorimetry. It is like perceptual, but the white point of the print is mapped to the white point of the digital. It's slightly complicated, so just remember that it's slightly like this. And saturation, here the saturation of the color will be exaggerated at the cost of the detail. The detail will be less visible, the saturation of color will be more visible, highly visible. Okay. So this is now in Photoshop color setting. So when you make a profile, you load these profiles here. Okay, RGB profile here if it's RGB, CMYK profile here, dot gain here, then other settings, and then this you save as with particular name. So when you recall that name, all settings will automatically come. So if you are using Adobe Suite, and if you say this setting you have applied in Photoshop, then you go to what is called Adobe Bridge. In Adobe Bridge, if you click on this, the same setting will go to Illustrator, same setting will go to InDesign, same setting will go to PDF. So all your Adobe Suite will have exactly the same setting. So when you make your prepress, your file, and send it for PDF, it will not change. If PDF has a different profile and here you have different profile, it is going to change. You must have the same profile also in PDF. You must have the same profile in PDF so that your colors will be consistent, your picture will be consistent. Okay. So that you do through this is something not available in CorelDRAW. That's why CorelDRAW is alright for designing, not for the prepress. I think for the prepress it's a useless software. So if you are working in CorelDRAW, you export your files to Adobe Suite, and then you apply color management. So you have to keep whole process under control to make sure that your colors come right. Then only you will get good color match. So computer to in digital reproduction is very important because you don't know what is happening inside the computer. Your ink preparation must be good, especially in packaging. Okay, we call ink kitchen. Color matching must be good. Then in spite of doing all this, sometimes the color will still appear different because color is ultimately only in your eye. So if two colors are the same, but if one is coated, UV coated, that color may look slightly different. If there is a haze, if the paper is texture, if the box is converted, viewing angle and the surrounding area, this makes color appear slightly different. So this you have to keep in mind. So that is called appearance science, color perception and asset. One of my good friend who is a famous visual communication artist, he has this definition for art: absorption of light rays, or reflection or refraction. T is transmission. So art is nothing but the science of rays. So if you control all this, then you are a winner. Okay. So this time is not enough for all this, but I try to cover the whatever. What is time now? We have still one more. I will show you. So far, okay. Now how many are here from packaging? Yeah, because when it comes to packaging, it becomes little more complicated. Okay, look at color accuracy in packaging printing. So in packaging, you use variety of substrates and variety of printing processes. Okay, there is a very, very wide variety. Tubes. Okay, so in packaging, when customer is shown the proof, this is a common practice. They show light, medium, dark. Yeah. The problem here is there is no numerical value, so it's difficult to say when you print how light, how dark. It's difficult. So still most people are following this visual approval. Printing process is like a musical orchestra. If all the departments work in cooperation, the final result is good. It's like music. In music, even if a single person is out of tune, the music is spoiled. The same thing happens in printing. So this we had seen before, so I will skip this. Color exists only in the eye. This also we had seen last time. Light source is important. Viewing conditions. So you need a control light. Okay, so we have color in 3 stages: color creation, color measurement, and color management. Okay, these 3 must be followed in a systematic way. So in packaging colors, we use CMYK, or we use CMYK plus additional colors. Sometimes we have just spot colors. Sometimes there are some very special colors. Then pastel colors, metallic colors, pearlescent colors. These are all variety of colors we use. So there it becomes more complicated. This I'll skip. So depending on your application, after printing the basic test form, we can also select what kind of test form can be used for a particular company. Okay, this has now variety of pictures. Somebody who is doing a lot of skin tone pictures, we can use this kind of form. Or for with many special colors, we can again have some form like this, okay, with special colors. So spot colors like PNG, or special color like Cadbury's. So color evaluation, we must measure all the colors using spectrophotometer, spectral values. Then we have to make sure that color match achieved spectrally. We have to also measure ink spectrally to make sure color match is achieved, including finishing process, that is after coating, lamination, or UV. That's why I say do not trust only LAB values, measure spectral colors. And do not trust only Pantone number, because Pantone in different books will be different. It will look different. It's not the same. Then there are many colors which become individual component in the final printing ink, depending on the process. Okay. So in the printing industry, in some processes they use the dye-based inks, which, see, there is a wide variety. Also in pigment there is a wide variety. Red, there are 49 different red pigments, orange 12, and so all dyes and pigment together it is something like 239 different colorants. So these are the basic colorants with which you make your inks. So the quality of that is also important, because in packaging you have to get the right color. So test form analysis, when we do, we have to print on the production substrate and the inks which we are going to use in regular production. Special color values of the substrate and inks must be noted, must be written down. Some printed sheets coated with aqueous or UV varnish depending on your process. Some printed sheets are laminated. All color measurements and profiles calculations done at various stages. Gloss measurement of the substrate and ink is also done at various stages, and the substrate brightness noted, how bright, okay? Because some pastel colors will look good only on the bright papers. If the paper is not bright, the pastel will not look bright, it will look dirty. So the ink management is very important. So on press management, so some ink management has now come on some printing machine, some gravure and flexo machines. Anybody doing gravure, flexo? No, all offset. So there are analog tools and digital tools. Analog tools are color chart, Pantone catalogs, and so and so. Digital tools are these electronic devices which will measure the color in terms of LAB, dot percentage, RGB values, and so and so. So Apple Macintosh and PC, this is the difference. Color sync system level workflow, profile verification and correction, color gamut comparison, all possible on Mac. Poor system level workflow on PC, system is dumb. Monitor calibration we talked about. Origination and design, poor software, Corel Draw, MS Office, PDF. Good software, Adobe Suite, PDFX, some proprietary softwares. Special multicolor. In prepress, these are good software, Adobe Suite, PDFX, some special multicolor or proprietary. In prepress, adapt customer file as far as possible as RGB files. Use Adobe Photoshop, InDesign, Illustrator, or some proprietary software if you have special requirement. So measurement system, densitometer, colorimeters or spectrophotometer, we talked about it. This we know. So in densitometer, there are two kinds of filter sets. One is called status E, one is called status T. Status T is American, status E is European. So that works, European works better as far as the density measurement is concerned. It gives you realistic density values of the ink deposition. These are called narrowband filters. Then polarization filter. Americans don't use polarization filter. European they use polarization filter. So your difference between wet ink and the dry ink is less if you use polarization filter. So this is better. Colorimeter, we saw it works at 3 points. Then there are setting like 2 degree and 10 degree. In printing industry, we use 2 degree setting. Okay, colorimeter gives metameric match. So you have to go spectral, measure the spectral values of the color for better information. This we saw. So there are various systems available. One is called camera color measurement. That is also becoming common now. Offline color measurement. You take the sheet, measure it. Online color measurement. This is on the machine when you measure and you can send signal to the machine. Okay, for ink zone adjustment. And there is an inline color measurement, so that as soon as it is measured, automatically the signal will go for the ink setting. Okay, and the color is corrected. So this is a measurement geometry. For normal densitometer, this is what you need, called 0, 45 or 45-0. The light measurement should be this way in the instrument. But this system is not good if you are printing metallic color or metallic substrate. So you need what is called another one, SPM densitometers or multi-angle, which are better to measure the metallic colors. integrating sphere. Okay. There are multi-angle measurement for metallic colors. So in color management, you get the instrument, and there are higher level instruments where your measuring instrument will move automatically on the chart. Okay, this is what I use. Then you get the color gamut, like we discussed before. So this is compression, and then you measure the customer sample and you measure your print. It will give you what is called the delta E. What is the color difference between the customer sample and your sample in terms of color? So that we measure, and there are 5 different formulas. The latest one is the 2000 formula. So we have to make sure we are using the right formula every time we measure what is the color difference. So one is 76. So the size of the ellipse shows that within that ellipse, when the color moves, it still looks the same. Okay. So as you go to saturated color, your tolerance is more. In the center, in the gray, the tolerance is minimum. So this is with 76. This is with 94 formula, which is improved on 76. But your meter will have all the 5 formulas. This is with CMC, color matching committee of dyers and colorists. This 2:1, 1:1, and this is 2000. So 2000 is the latest formula, so you must make sure with what formula you are measuring your delta E. This is very important also to measure the inks when you get the inks. This we talked about various printing processes. So you need to add the strip, and you have to give the tolerance, lower and upper tolerance, using this LAB values. Okay, not just visual, light, dark. You must measure like this and give the numerical value. Then it's easier to control on the machine. So there are other aspects which still affect color, like we talked: gloss, texture, shape, surrounding, viewing angle, viewing distance, size, haze. So this is concentrate on the circle, center of the circle for short time. Can you see something? Yeah? You see the flag of India, but there is nothing. So this is called color appearance. Yeah, there is nothing, but still you have after effect of the color. So this is what happens even after measuring. There are some color appearance. This is called color appearance. So this is something which will still make some changes even after measuring. This I showed you. So all these factors must be kept under control, because everything affects ultimate printing. Your preventive maintenance, your condition of the machines, your viewing light, ink control, paper control. Because printing is a combination of all this. So you keep control, and then you can get good printing. Okay? Yeah, any question? If you don't have questions, then we are through. If you have any questions, you can ask.
Yeah.
As you told, there are 5 formulas to calculate delta E value.
Sorry?
As you told, there are 5 formulas to calculate delta E value. What is the difference between that formula?
I showed you the size of the ellipse.
Yes.
The tolerance changes. Tolerance change. Sorry?
Can you show it again?
So you have to work on the right tolerances. Okay? This is the oldest formula. Then this is improvement further. Yeah. But ultimately color is, you have to see with eyes. So the smaller the tolerance is good for the match. Yeah, Irene, what is next? Last time we had some more people from packaging, no? I think DCPL was there.
Yeah.
They are not come this time.
You said the latest model, right? 2000 model.
Yeah.
That is the spectral photometer model you are saying?
No, it's a formula which is programmed into the instrument. So I have the instrument in that all the 5 formulas are there. So I have to select which one I want to use.
Gets upgraded with time, those formulas? Or there's just 5 standard formulas?
No standard. The last one was 2000 improved.
Yeah, so now it's 2016.
But no formula has come out after that.
Acha, that's the last one.
That's the last one. The first one was in 76. But that did not match visually correctly, so they improved on the formula.
They still kept it in the instrument.
Yeah. Unfortunately, in the printing industry, people are still using the oldest formula. I don't know why.
Who is it? You're not using the 2000.
No. Now only after talking to some people, okay, but they still talk about 76. Even though the standard. So I also recommend it because I'm also on the standards committee. I review international standard. So I see in the new standard they have given both 76 and 2000.
Except for a few customers in the packaging, the high-end, the multinationals, the rest of the industry doesn't know much about LAV and these
No.
things like that.
They don't know about the densitometer. They don't even know about
Yeah,
densitometer.
they still depend on line standard.
Yeah.
You know, that's what they can see. Even if I give a strip,
They're difficult to match in printing. Like
yeah, even if I give a strip, they don't have any
No.
way to measure it.
yeah. But it's for your reference it is good. Yeah.
And,
Anything else?
the shade cards also have to be changed periodically.
Yeah. Or you have to go for electronic. Measure the customer sample.
So when someone gives you a sample, say, customer says, okay, this is the sample I printed
You
last
can measure that.
So as a first step, I mean, he doesn't know what shade it is.
No, you measure it.
With the spectrophoto.
You measure it and you try to get your ink matching to that.
Including including the Pantone.
Yeah. Yeah. Any other? Okay. Then you can enjoy your day. Students are waiting. Okay? Thanks.